All right, let's take a look at example 1 in your notes. Looking at this equation in standard form, we see the vertex is, and of course we're looking at a parabola because one thing is squared and the other isn't, okay? Remember, HK is what we're looking for. So we have 2, -3. That is the vertex. P, remember that 8 is 4p, so 4p equals 8. P equals 2. Because the x variable is the one that's squared, we know it opens either up or down. Now, of course, I'm giving you the graph, but you're going to have to come up with a graph on your homework. So this is what we look for. Because x is squared, I know that it either opens up or down. If y is squared, it opens either left or right. Okay? Because the x variable is the one that's squared, we know the parabola either opens up or down. Because p is positive, it's a positive 2, we know it opens up. Okay, and the absolute value of p, of course, is 2. And that, remember, the absolute value of p is the distance from the vertex, which is right here. The vertex is 2, -3. And we have 2 away from that is the focus, and also 2 away from that is the directrix. Well, the directrix is a line, and it's this line right here. Okay, it's this line. Okay, and so make sure for the directrix you put equation of a line. The focus is a point. It's, in this case, it's 2, -1. Remember, we got that by finding p first, and we know that this is the parabola, and inside the parabola is the focus, and the parabola is always opening away from the line that we call the directrix. Well, it crosses the y-axis, and so y equals 1, 2, 3, 4, 5, -5. Y equals -5 is the equation of the directrix. Remember, the directrix is a line, so we need an equation for that. A little tip for graphing, take a look at these 2 green spots here, these green points. Okay, when we graph, we want to find these 2, I'll call them easy points, but it's based on the definition. I know these 2 green points are on this parabola because these green points are equidistant, same distance away from the focus and the directrix. Okay, and that's always 2p. See, p is 2. Well, the distance between the focus and the directrix is 4. So I go from the focus 4 this way and 4 that way. That makes these 2 points 4 units away from the focus and 4 units away from the directrix. By definition, those have to be on our parabola. So sometimes we use those to make sure our parabola looks right, that we don't accidentally graph something that's way out of whack. All right, let's take a look at the next. Here we have y squared equals -12x. Of course, it's the same as y minus nothing squared. So we see that the vertex is 0, 0. I got a weird pen going on here. All right, and then we find p. Of course, remember that -12, that's 4p. So 4p equals -12. Divide a 4 on both sides. You get that p is -3. Okay, keeping in mind that you're going to have to come up with the graph. Make sure that you understand where we're getting these things. Okay, so this is the same as that. The vertex is that, and p is -3. All right, here's what we're looking for now. We're looking to see if it opens up, down, left, or right. Yes, I know you're looking at the graph. Okay, bear with me here. So the parabola opens because the y is squared. Get rid of that hexagon there. Here we go. Because the y is squared, I see, and p is negative. That's why it opens to the left. Okay, y squared, so that either opens left or right. If p is positive, it opens to the right. That says left. Okay, and then the focus. Well, the focus, remember, we're going to go the absolute value of p, so 3 units. Okay, because p is -3. We see that the focus is going to be over here. The focus is on the inside of this parabola. 1, 2, 3 p units away from the vertex. I'll put a v for vertex, and there's the focus. I'll put an f there. Okay, so the focus is -3, 0. And the directrix, remember, the directrix is a line, so we need an equation. In this case, it is a vertical line, but remember that it's 1, 2, 3 units away. Make sure you don't put it as a point. It is a line. It crosses the x-axis, so it's x equals something. And in this case, it's x equals 3. Okay, we got it. All right, let's do example number 3. And in example number 3, we got to graph the thing as well. And so as we're finding this stuff here, we'll just add to our graph. So we see the y is squared, right? And so it either opens left or right. P is positive, okay? So we should be able to figure out that it opens to the right. If y was squared and p is negative, it opens to the left, right? If x is squared, it would either open up or down, okay? So let's write down the vertex. The vertex, remember, it's hk. So h is over here with the x, so I got negative because it's x minus h. So it's the vertex is -3, -2. Let's find that on the graph. -3, -2. -3, -2 is right there, right? -3, -2. Okay, now 4p is 10. Okay, 4p equals 10. And so we got to figure out what p is. Well, 10 fourths, that's 5 halves, that's 2.5. So I'm going to write it as 2.5. Okay, all right, y is squared, p is positive. It opens to the right. The focus. Well, remember, the focus, we're going to move, because this opens to the right, I'm going to quickly sketch this. Don't put this in your notes. Oh, that changed. All right. So it looks something like this, right? But it's that's just a rough sketch. So don't put that yet. I'll show you how to get a better graph. I just kind of want to remind myself. Maybe I should just put it off to the side then. I just wanted to remind myself that it opens to the right. That helps me remember which direction I go for the focus. So the focus is going to be on the inside. Here's the vertex. I go this way for the focus, and I go to the left to find the line that we call the directrix, okay? So here's our vertex, and I go 1, 2.5. There's our focus. So the focus is -1/2, 2. -1/2, you can put 0.5 if you'd like, comma 2. There's the focus. And the directrix is over on the other side, 1, 2.5. And so here's this line that goes through -5.5, but it crosses the x-axis. And so I know that it's x equals -5.5. You can put -5.5. Okay, now we have to graph this, okay? And so the way we're going to graph this, let's change my color here. All right, where we're going to graph this is we're going to find the two easy points. Well, the two easy points, they're only easy if you remember how to do this, but it's based on the definition. Remember, the definition of the parabola is all the points, set of all points, equidistant, same distance away from the focus and the directrix, okay? And so if we figure out what that distance needs to be, like this distance right here between the focus and the directrix, well, that is 2.5 plus 2.5 is 5. So what I'm going to do is I'm going to go up 5, 1, 2, 3, 4, 5. Now I know this point has to be on my parabola because it's 5 units away from the focus and it's 5 units away from the directrix. Okay, so that point has to be there. And I go 1, 2, 3, 4, 5, and that has to be there. Now the rest we're going to eyeball a little bit. Make sure you get close though, don't do something like that. Okay, all right. And so we know that it's a curve, and I don't know. Okay, I'm not an artist, but make sure that I see that the vertex needs to be there. That easy point, the heck am I writing with here? And then that point right there, okay? All righty, let's take a look at the next example. I take that back. We're going to end this video here, and we're going to jump to the, excuse me, the other page of notes, and then I'll tell you what your assignment is. All righty, let's go to video number 3.